Hi everyone, we're going to look at how to do dividing with exponents here. So what we're going to do is we're going to first figure out the rule by writing these out. So the first one is x to the fifth divided by x squared. So what does that mean? Well, that means x times itself 5 times divided by x times itself twice. Now we look for things to cancel out. 1 on the top, 1 on the bottom. Multiplying and dividing are the same thing, eliminate each other. Same thing, one more. So we're left with 3x's up top, which is x cubed, and nothing left in the bottom. But we can't call it 0 because you can't divide by 0. So you can put a 1 down here, since multiplying by 1 doesn't change anything. So this is actually x cubed over 1, which is just x cubed. And hopefully you can kind of see the shortcut here. So if it's dividing with the same base, we keep our base of x, but the exponent gets subtracted. So 5 minus 2 gives us the 3. That's our shortcut for dividing, which you don't have to memorize because you can always just write it out and then just eliminate things that go together. So for the next one, very similar. This is x to the fifth, so 5x is being multiplied, divided by x to the eighth. 5, 6, 7, 8. It's a little tedious when you get bigger exponents here, but it still works. Again, eliminate one top, one bottom, until you can't anymore. And what's left this time? Well, there's nothing left up top, but there's 3 x's in the bottom, so x cubed in the bottom. Again, can't put 0 in the top here because that would make the whole thing 0 if I put 0 there. So you can't do that. We can do a 1 since times 1 doesn't change anything. So it's 1 over x cubed. Using our shortcut, we would keep the base of x and then just subtract the top exponent minus the bottom. That would be x to the negative 3. Now, when we get negative exponents, what we're going to do is we're going to put them in the other part of the fraction. If we put this over 1, it makes it a fraction. So from the top, the x cubed would go to the bottom and become positive. And again, nothing left up top has to be a 1. You can't leave that blank. And that's why it's 1 over x cubed. Okay, another quick couple examples here. We've got another division problem. I split these problems up into the numbers and the x's like this. And then I just divide the numbers here, so that would be 5. And then the x's, well, again, keep the base, subtract the exponents. So that's 5x to the fourth. If you want to write it all out, you can, but you definitely don't need to. For the next one, very similar. Do the numbers together. Do the x's together. And then do the y's together. We just have y's this time. 8 over 4, you're dividing, remember, so that's 2. X to the 6 over x cubed would be x to the third. Keep the base, subtract the exponents. This would actually be y to the 0. Now, anything to the 0 is just 1, which you don't have to write times 1. You can just call this 2x cubed. And then we've got a couple more here, very similar. So I'm going to do this one, 6 over 2, x to the 7th over x to the 5th. And then y to the negative 3 has no y's to go with it in the bottom, so I'm going to put it by itself. This would be 3x squared y to the negative 3. Again, for negative exponents, they really shouldn't stay negative. You should put them in the other part of the fraction. So we're going to move that down here and make them positive. The 3x squareds, those stay up top because those have positive exponents. But this one goes to the bottom and becomes a positive 3. Now, the 3 doesn't have an exponent shown, but really it's a positive 1, which is why it stays up top with the x squared. So that would be 3x squared over y cubed. For the last one here, looks kind of crazy, but it goes the same way as the other ones. Just do it piece by piece. 12 over 4, x squared over x to the negative 3, y to the negative 3 over y to the 7th, and then our z's. Z to the 5th over z to the negative 6. Lots of negatives here, lots of pieces, but we can do this. 12 over 4 is 3. For this one, it's going to be x to the 2 minus negative 3. The y's are going to be negative 3 minus 7, and the z's are going to be 5 minus negative 6. So many negatives. Okay, so 3x to the minus becomes a plus. So that's x to the 5th. And this would be y to the negative 10, and z to the minus again becomes a plus. So now just bring your negative exponents to the bottom, and we get 3x to the 5th, z to the 11th, over y to the positive 10. Since you've got the negative exponent puts in the bottom becomes positive, and that's how we can do that one simplified form with all positive exponents.